Hi, so in this video we're going to be applying proportions to another type of problem. These problems will all involve scale. And when I mention scale, I'm not talking about like the scale you use to weigh yourself. In math, scale and scale drawings are talking about how you take like a large object and you draw it smaller, or you take a smaller object and you somehow enlarge it and make it smaller. And when you do things like that, I have a sister-in-law who's an artist, and she often draws pictures of people, and so she might start from a small photo, but then she wants to do a larger portrait of that person. She'll measure the actual size of the person's eye on the photo, and then she'll multiply that by a certain number in order to make the eye that she draws on her canvas bigger, so that it looks more like a normal eye. But then when she enlarges, say, like the nose, then she wants to multiply that by the same amount in order for the scale to stay proportional. Because you wouldn't want a really big eye and a really small nose, because then it doesn't look like the actual person. So that's the kind of scale we're going to be talking about today. So scale drawings and scale models are used to represent objects that are too large or too small to be drawn or built at actual size. And so again, like another example of this would be like when you see the map of Texas. That's something that, you know, it's not the actual size of Texas, of course, because that wouldn't fit on a piece of paper, but it's been drawn down, but they've used the same scale for everything they've made smaller so that it still looks like Texas, just smaller. Yeah, same thing with like a model car. They look like little bitty cars, and that's because they've shrunk everything the same amount so that it stays proportional. And that's one of the characteristics about scales, is that the scale that they give is a ratio that compares the measurements of the drawing or model to the measurements of the real object. And then those measurements on a drawing or model will be proportional to the measurements on the actual object. And since they're proportional, we can use proportions to figure out some of the questions they ask about scale models and scale drawings. So here's a typical problem where they might give you a picture of a map and then have you figure out, based on the map, how big or small the actual distance might be. So on this map, each grid, so that's each square, represents 50 yards. And they want you to determine the horizontal distance from Patrick's Point to Agate Beach using that scale. So with any proportion, we're going to start by setting up our word ratio. So a couple of things we could use for this. We could do the map scale compared to the actual size. So in this case, we would set up our boxes. And we know for the map, 1 unit or 1 square is really equal to 50 yards. So that would be 1 over 50. And then if I want to know how far apart Patrick's Point and Agate is, I need to know on the map how far apart they are. So this part I can count. Horizontal is, of course, left to right. So this would be 1, 2, 3, 4, 5, 6, 7, 8 squares. And then the actual distance is what I'm looking for. So I'm going to replace that with an x or some kind of variable to show that's what I'm solving for. So with any proportion, the next step is just to solve using your cross product. So 50 times 8 is going to be equal to 1 times this unknown that I'm trying to figure out. So 50 times 8, if I multiply those two numbers, I get 400 equal to 1 times something. Well, this is normally the part where after I multiply, then I divide by this number right here. And because normally I don't know what this would be, but I know that 400 divided by 1 is still going to be 400. So I can go ahead and skip and say that 400 is equal to x. And because I'm talking about yards here, I want to make sure I include my unit of 400 yards. And so really what I've said is that, okay, well, based on the map, since these are 8 units apart, then in real life, in all actuality, those two places are 400 yards apart. So let's look at the second example. Again, they're talking about a map of California this time. The distance between Los Angeles and San Diego is 6.35 centimeters. If the scale on the map is 1 centimeter to 20 miles, what's the actual distance between Los Angeles and San Diego? Okay, so again, I could do map to actual, or I can maybe just look at the units here. I'm going to be comparing centimeters to miles, so I can use those. as my ratio. And then I can start with this first scale they've given me. I know that 1 centimeter is equal to 20 miles, so I want to make sure I line those up in the right box. And then I'm trying to figure out what 6.35 centimeters is in miles. So 6.35 is going to go on top with my centimeters. Miles is what I'm looking for, or the actual distance is what I'm looking for. So that's going to be X or A or whatever you want to use. Now that my proportion is set up, I'm going to cross multiply. So I need to multiply 6.35 times 20. Start with a 0 and get all zeros. And then my second row, I start with a 0, and then I'm going to start with 2 times 5 is 10. Here your 1. 2 times 3 is 6, plus 1 is 7. 2 times 6 is 12. Add these up. And then don't forget you're multiplying decimals. So since you have 2 decimal places here, that means you need 2 decimals in your answer. So I'm going to move that over. Get 127.00, which is really just 127, equal to 1 times x, which I know anything times 1 is just itself. Or I can think of dividing 127 by 1. It's still going to be 127. And then my units here is what I was looking for, was in miles. So my answer is going to also be in miles. Okay, and so basically if we interpret our answer, what we're saying is that because Los Angeles and San Diego are about 6.35 centimeters on the map, that's not how far they really are, that's what the distance was on the map, then if I use the scale, knowing it's 1 centimeter is really 20 miles, and they're actually 127 miles apart. All right, and then in this third example, now I'm talking about a model car. So the box of the car reads that the scale is 1 inch for every 2 feet. If the actual car is 20 feet long, how long is the model car going to be? So this is going to be actually smaller, right, than the 20 feet, if that's the actual size of the car. So I'm going to start again by making a proportion. I could do inches to feet, or I'm going to go ahead and go back to model and actual this time. So I'm going to let those be my words. I'm going to set up my boxes. And I know in the model, the car is 1 inch. You can even write the units in there if you want to. And the actual car is 2 feet. Or you could just use the 1 and the 2, it doesn't really matter. And then the actual car is 20 feet long, so I'm going to write the 20 here because that's the actual size. And the model is what I'm trying to figure out how big that is. All right, so again, I'm going to be multiplying 1 times 20. And that's going to equal this part right here, 2 times x. All right, 1 times 20 is just 20, and then 2 times something is going to give me 20. So if I don't know what that is, if I can't just figure that out, then I'm going to divide by 2, which is normally how I solve a proportion anyway, right? I multiply across diagonally, and then I divide. You can think of that as the baseball bat and the ball there. 2 will go into 20 10 times. So my answer is x equals 10, and I'm looking for the unit. The model is in inches. This is going to be 10 inches. So the actual model car is only 10 inches long, not 20 feet long like the car. So when scale is expressed as a ratio using the same units and in simplest form, it's called the scale factor. So if we go back to that last example, the scale factor in example 3, if we see what we started with, we really started with 1 inch over 2 feet. Oops, let me start it. 1 inch over 2 feet. All right, so you can see that inches and feet are not in the same unit. So this is not scale factor. But I could make it scale factor if I change these and say that they are the same unit. So 1 inch, I can't change 1 inch into feet, but 2 feet I could change into inches since I know that 1 foot is 12 inches long. So I know that 2 feet would be 24 inches long. So I'm going to rewrite this as 1 inch over 24 inches now instead of feet. And now you can see inches to inches, that's the same units, and this is simplified. So the actual scale factor for this is 1 over 24. You don't usually include the units there. And what that means is, for the model, what we're saying is that the model, the little part, the little car, is 1/24 the size of the actual car. So it's much smaller than the actual car. Or you can kind of read this going the other direction, thinking of the actual car being the 24. The actual car is 24 times the size of the model, right? So that's what scale factor is talking about there. And that is how you use proportions to solve scale types of problems, scale drawings and scale models. All right, thanks.